Finally, we've learned 3 different techniques of factoring, and you might be wondering, what the heck do we need these techniques for? Why do I need to factor in the first place? The answer to when you'd use factoring will change as you go through the math curriculum. They'll be used for different things, but we're going to use this particular technique to solve equations. If I'd given you this equation back in the fall, you couldn't have solved it. You see, you can't get x alone because you've got x in 2 different terms, and those x's can't be combined because they're not like terms. So there's no way to isolate the x. The best we could do is isolate the 2 terms with the x, but that wouldn't tell us about what x actually equals because we wouldn't be able to solve it to just equal a number. So here's where factoring is going to become useful. We're going to factor this, and if you remember right, our 3 techniques of factoring were to do greatest common factor. Always check for a greatest common factor first. Then look and see if it's a difference of 2 squares, if it happens to be a 2-term thing. See how this has 3 terms? It's not going to be a difference of 2 squares. And then finally, if it's a trinomial especially, we're going to use our trinomial trial and error factoring. So let's kind of begin. There's some steps we're going to follow. We're going to get it set equal to 0. We're going to factor the side where everything is. And by factor, I always mean factor fully. So factor fully. Step 3, set the factors equal to 0. So when we're all done factoring, we're going to take every factor we see and set it equal to 0, setting up multiple equations. And then we're going to solve those equations, solve equations. And this style of equation will be like the type we've done all year long, getting x alone. So let's go ahead and apply this algorithm. An algorithm is just a fancy word for an ordered list of steps to do something. Let's apply this algorithm to this problem right here. Get it set equal to 0. Do you see how there's a 0 already alone on one side? Well, somebody already did step 1 for us then. If this had been a negative 6 over here, I would have added 6 to both sides to bring it over to this side. But I need a 0 on one side of the equal sign. Now we're going to factor. Let's see if there's any number that we're going to look for a greatest common factor first. Is there any number that goes into 3, 19, and 6 evenly, meaning without any remainder? You might wonder if 3 works, but it doesn't go into 19 evenly. It misses by a little bit. So it turns out in this problem, there is no common factor. So no GCF. That's always the first type of factoring you attempt. The next thing, I'm looking to see if it's a difference of 2 squares. I abbreviate that difference of 2 squares just because it makes a nice pronounceable word, dots. Well, it's not 2 terms, so it's definitely not 2 anythings. So it's not going to be this type. It does have 3 terms, so I call that the trinomial trial and error, which means to try the combinations. It's the most difficult and most recent form of factoring we've learned. But with everything, practice makes us better at it. So no common factor. It's not 2 terms, so it's definitely not a difference of 2 squares. So it's a trinomial. We're going to try to set it up with the 2 sets of parentheses. Remember, if it had been a greatest common factor, we'd be setting up just 1 set of parentheses, and we put the GCF out front. With differences of 2 squares, we always set up 2 sets of parentheses. And with trinomial trial and error, 2 sets of parentheses. So we've got our 2 sets of parentheses. Remember that we have to look, we know the first things have to multiply to give me that term right there. There's a very limited number of numbers that times each other give me 3. That's the only pair of numbers I can think of. So I'll put a 3x and a 1x. Remember, the reason we need the x's is we don't want to get 3. We want to get 3x squared when we FOIL out. We know that what goes here has to multiply, the two number terms have to multiply to give me the number. So with a 6, there's 2 possibilities. So one pair of possibilities is 1 times 6. The other pair of possibilities is 2 times 3. And I don't know for sure which one is going to work. I usually try the 2 close together numbers first. That may or may not be helpful. We can try it. I'll put a 2 here and a 3 here. And remember, that middle term is the one we're wondering if it comes out okay. So what we'll do is, we don't have to keep on checking this over and over. We've already only put the only possibilities out here. And we don't have to continue checking these, because this list here are the only numbers that are possible to get me to 6. So it's that middle term that comes from the outers. Multiplying these together gives me 9x. And the inners, 2x times 2 times 1x is 2x. And if I have my way about the signs, no matter how, whether I make them positive or negative or a mixture, can I ever get a 19x if I combine them? No, this would either give us an 11x or perhaps some version of a 7x. It just means that the 2 can't go here and the 3 can't go here. Remember, when these are not alike, we have to switch the order to see if that pair, but just in the reverse order, might work. Outers, 3x. Inners, also 3x. Will that ever combine to give me a 19x if I can play around with the signs? No, it won't work out. It'll either give you no x's or give you 6x. So that didn't work. The 3 and the 1 here are our only possibilities, so I'm certain about these. But I had 2 possibilities here, and I just tried the 2 and the 3 both ways. So now it's a time to try the 6 and the 1. If I put the 6 and the 1 like this, the outers give me 3x, the inners give me 6x. Can that ever add to a 19x? No, it can't. So I think we're going to find our answer once we set it up like this. Outers give me 18x, inners give me 1x. Can you add or subtract these in order to get a positive 19x? Well, yes, these will combine to be 19x if they're both positive. So I go put the plus signs here and here. And remember, you always make sure that this times this gives you the proper sign. Positive times positive does indeed give me positive. I didn't need to check the size of the number because my list ensured that I got the right number. So what we've just done is we had already had it set equal to 0 from the start. Then we fully factored. Is there anything further I can do? Is there anything common to both terms? No. Anything common to both terms? No. So we're not going to be taking any of our factors and breaking them down further. Set each factor equal to 0. So I'm going to take the 3x plus 1 and I'm going to set it equal to 0. I'm also going to make up this equation where I set the other factor. Remember, factor can stand for either the process of writing it as multiplication, but the other meaning of the word factors are the actual quantities multiplying each other. So this is one factor, I set it equal to 0. This is another factor, I set it equal to 0. Now I solve these little equations that I formed. So I'm going to go ahead and bring the 1 over, and I'm going to divide by 3. And I see that x equals negative 1/3. That is one of my answers. Now these equations are a little different from ones we did earlier in the year. Most of the equations we did, all of them except the absolute value kind, had just one answer. The absolute value kinds of equations actually had some equations that had two answers, but these equations are often going to have two answers. The other answer is going to come from coming over here and getting x alone. So let's get the 6 out of town. And there's your second answer. So there were two numbers in the world that if I put them in for x, like if I took the -6 and put it here and here, it would all simplify to 0, and 0 would equal 0. If I put in -1/3 in every occurrence of x, believe it or not, when I put in a -1/3, this all simplifies to 0, which would equal 0, and therefore is a solution. So solving equations by the factoring method means getting a 0 here, writing this as a product by factoring using one of our three techniques, whichever ones are the appropriate ones, then taking each one of these and setting them equal to 0, and then solving those individual equations that we formed. There, you just solved your first. The fancy word for an equation that has a 2 up here is a quadratic equation. You just solved your first quadratic equation. Okay, let's try solving another equation that we couldn't have solved back in the fall. I want to take a screenshot. This would be a good time. Okay, I'm going to leave the directions up so we can make sure we're adhering to them. Okay, next equation. This would be example 2. And the next equation that we're going to do is going to be 16x squared minus 25 equals 0. Well, isn't that nice? Somebody did step 1 for me again. It has to be set equal to 0. All of this is here and it's set equal to 0, so I don't have to do anything to achieve that first step. Now it's time to factor this side. Is there a greatest common factor, a number that goes into 16 and 25 evenly? No, there isn't. Are there x's in both terms? No, there isn't. So we're all ready to see if maybe a difference of 2 squares might be appropriate. Is that a perfect square? It is if, so you can think of a quantity times itself that gives you this. I think 4x would work. And here, 5. And is that a different sign? It is. So it's a difference of 2 squares. So we set up our 2 sets of parentheses. You put here and here what multiplies by itself to give you this. You put here and here what multiplies by itself to give you 25. And you put one of each sign. We're all done doing step 2. This is factored. Nothing goes into both terms. Nothing goes into both terms. Neither factor will break down further. Remember, you should always factor completely. Okay, most of the time when you factor it, it'll already be fully factored. Let's take a look at, am I done? Sure looks like I've done a lot of work. Am I done? No, because I still have to set the factors into equal to 0. And form these little equations. And now it's time for me to solve the equations that I just formed. So minus 5 to both sides, 4x equals -5, and then divide by 4. And you can turn it into a decimal like 1.25. This would be -1.25. Or you can leave it just like this. If it comes out to be like 8/4, yes, write 2. But if it doesn't go in evenly, you can just leave it as a fraction if you like. There's an advantage to leaving it as a fraction. it's exact. Whereas sometimes the decimals come out with stuff after the, sometimes if you do the division out, it comes out to a messy decimal. Add 5. Divide by 4. X is equal to 5/4. That's not the same number as negative 5/4. So those are the two answers. Okay, take a screenshot if you wish. You all know you take a screenshot by pressing the home key and the power key on the iPad at the same time. And I think we're ready to try another example. You all must be pretty anxious for summer break, where you don't have to look forward to seeing my face every day. Now here's another problem. 3x to the third minus 300x equals 0. This would be example 3. That's a lot of 3's. Anyway, so we have to get it set equal to 0. Oh, look, already set equal to 0, so somebody already did step 1 for me. Fully factor, you always check for a greatest common factor first. So in this case, there is a greatest common factor. So I see a number that goes into 3 and 300 evenly. That number is 3. And I see x's are in both terms. The most I can take out is the amount that's in the term that has the least. And notice I wrote the GCF out front and I had just one set of parentheses. So now it's time to figure out what must have been in here. 3x. I need 2 more factors of x. So x squared goes here because we're going to add the exponents, right? And then 3x times a negative 100. Let's double check that. Whenever I factor out a common factor, I make it a habit to mentally multiply back to make sure it's equivalent to what I started with. That times that does give me that term. That times that does give me that term. So everything's all ready to go, right? We've already factored. We need to fully factor. And in this case, this will stay as it is, but this thing fits this category, difference of 2 squares. So I'm going to, this is part of the factoring completely that we did on the last worksheet. So I'm going to bring the 3x down, but I'm going to look for a new way to write this. And it's a difference of 2 squares. So I'm going to use this set of parentheses to replace that. What times itself gives me this? X times x gives me x squared. What times itself gives me 100? 10 and 10. Put one of each sign. This is equivalent to this. So when we brought this down, here's the 3x, but we wrote this a new way. Now we have factored fully. How many factors do you see? Remember, factors are the quantities that are multiplying each other. I think we have 3. Here's a factor, here's a factor, and here's a factor. In fact, we're going to set up 3 little equations. And we're probably going to get 3 different answers. So let's go ahead and solve this. This is not too hard to get along because I just have to divide by 3 on both sides. And 0 divided by any other non-zero number is going to be 0, because 0 times 3 gives me 0. Okay, so that's one answer. Doesn't mean there's 0 answers. It means 0 is one of the answers. Over here, there's another answer. here's our third answer. So we got 3 different answers out of this. Very good. Let's try one last one. If you want to take a quick screenshot of this, feel free. Make sure that these, if you don't take a screenshot, end up in your notes, because this will lay out for you how to do the homework. So the last problem we're going to do is x squared equals negative 3x plus 4. So notice, for the first time, nobody got it set equal to 0. We've got terms on both sides, no 0 on either side. It might seem like I should just bring this term over here, and though you can, I'm going to tell you right now, it's always a good idea to have all of the terms with that first highest powered term, the x squared term, with a positive number out in front. Right now it's positive. So I think I'm going to bring those 2 terms over here rather than deal with a negative x squared. I'll tell you right now that the factoring is a lot harder. To be careful with your signs if you have a negative coefficient out in front of the x squared. So I'm going to bring this term over here. I'm not going to be able to combine these 2 terms, but I'll have x squared plus 3x. And over here I'll have just the 4 now. And then I'll bring the 4 over to this side. Again, I can't combine a number term with either of the other 2. So I'll just keep all the 3 terms. And now I have it set equal to 0. Now it's time to factor. So there's no common, there aren't x's in all 3 terms. And there's no number that goes into 1, 3, and 4 evenly, except for 1 itself. We never factor out a common factor of 1. So this is not going to be done by greatest common factor. Is it a difference of 2 squares? No. It's got 3 terms, so it's not a difference of 2 anythings. Is it a trinomial? Yes. 3 terms. So we're going to do it by the trial and error method. You may talk to some other people in Mrs. West's class, but they will be using a different method perhaps of factoring, and that was the other choice I had, which of the 2 methods I would teach you for dealing with a 3-term thing. Their method is not wrong, it's just that I felt it was less likely we would master it in the time we had left. So for now, I put here and here something that multiplies by these 2 things have to multiply together to give me my squared term. Well, with just 1x squared, this is really our only choice. We have to put numbers here and here that multiply to give a negative 4. We leave the signs out of the picture, but we would definitely want a 4. Well, there's only 2 possibilities, 1 and 4, and 2 and 2. We can try the 2 and 2 first, or maybe you try the 1 and the 4 first. But do you see how putting these here already is sure that I get this? Putting these here is sure that I get some form of a 4. But the outers and the inners added together is where the middle term always comes from. The outers is a 2x. The inners multiply to 2x. This will not add to 3. So we chose the wrong pair to try. There's no use turning these around because they look alike and so do these. So that won't change what we get here for choices. But let's try a 1 and a 4. Okay, so now the outers multiplied together to give a 4x. The inners multiply together to give a 1x. And if I have my way about signs, how can I get a positive 3x? Well, I think if the 4x is positive and the 1x is negative, that would give me a positive 3x when I combine them. It will. So the positive, we want to have the 4x come out positive. So I'm going to go where the 4 is, and I'm going to make it be a positive 4. That times that gives me this. To get this, I want this times this, so I'm going to have to put a negative sign here. Remember, always check if the sign of this times the sign of that gives me the proper sign here. And a negative times a positive is a negative. That's good. So we just factored it. All that's left is to set each factor equal to 0 and then solve. And there'll be two answers again, just like we've had two answers for all of these. Those are the two answers for this equation. Make sure when I go through a lot of examples like this, know that you can pause as you go along and try to apply the other stuff to the later examples. Hopefully, if you use this as your guide, you'll be able to factor anything that will dish out for you in this next section. Have a good day.